Before getting started, there's a couple things I want to point out. I did just get the Caddx Dolphin in, and it's really interesting because it's a $50 camera that only does 1080p, I think 60 frames per second, but it has similar view and everything as a GoPro. I'm going to just go over it real quick. It doesn't quite fit in GoPro cases. You can kind of jam it in there, but it's a little bit bigger than GoPros, and it is a Caddx product, so it does come with the quality control issues that Caddx has been having lately. You can see that my lens is off center, and I think it's actually pointing in the wrong direction. It's not just off center. It's hard to tell when it's recording because the light is so tiny on it. This is not a full review, but I am going to show you the video that's coming out of the camera, and I'll do a full review a little bit later. One thing that's super annoying about it is that if you do want to install the app to change settings, which there are no settings, it's just one setting really, you have to give it your you have to first of all log in. You got to give it your phone number or log in with Facebook. Other thing I want to point out is that I literally have no idea what I did with the original Brother Hobby Avenger 2806.5 motors. I had them on this quad. I took them off. I cannot find them, so I can't compare it directly side by side to this motor, which I know is a big fail on my part. But this motor is really interesting. But I still have the Fywoo motor, which is a freaking awesome motor still. This motor is super interesting because this is the motor that DRL decided to go with for their Racer 4, which is incredibly interesting to me because DRL, as I've been talking to them during their development of the Racer 4, they did an insane amount of testing, and from a number of the pilots that I talked to, they told me I would have loved their setup because they just have test benches on test benches, just testing motor sizes and KVs and everything to get something that they're looking for. And there's a couple things I want to point out or talk about motors, which I'm going to talk about at the end because I'm going to share with you my experience that I know I'm going to get disputed on in the comment section below, but I'm really just sharing my experience with you just from testing a whole lot of things. That's going to come at the end. And one thing I want to say up front is that this is a 2510 motor. Unless you're comparing two motors that are built to the same exact quality spec and material spec, you can't really compare the sizes to one another. And this motor is genuinely different than the Brother Hobby 2806.5. The 2806.5 was developed after this motor as far as I know, and they did change quite a bit about that motor compared to this one. But first, let's go over the details of this motor and how it performs and that stuff first. So this is a 2510 motor in 1250 kV. I actually think that they sent me the 1300 kV, which is the one I requested, and I think that's the one that DRL is also using as well. They were a little bit hesitant about sending me those motors that DRL is using because Brother Hobby has a history of not being very loyal, but the past 4 years, they have been very loyal to a couple of customers and have been doing very right. So they have kind of turned a new leaf and are doing things much better now, much more on the up and up now than they were in the past. If anybody remembers back then, they did kind of sell out on the ZMX motors. ZMX is a group of people that hired Brother Hobby to make a motor, and it didn't really work out for ZMX when Brother Hobby decided to sell their motor design to other stores as well as their own design. But thankfully, Brother Hobby has turned a new leaf completely, and you can expect the absolute utmost in quality from Brother Hobby because they know how to make a motor, and they've made some of the best motors on the market for a long period of time. Now, I'm not trying to sell you on Brother Hobby, I'm just stating the facts because I've tested every single motor out there. And every time Brother Hobby makes a motor, they don't listen to me, and we do get motors that aren't what we want some of the times, but for the most part, they know what they're doing, and they're using good materials to make these motors. So this motor is no different. It is an Avenger line motor, so it is a top spec motor. You can expect the best aluminum, the best windings, the best magnets, the best design in this motor, except for some design choices, which are a little bit odd in my opinion, but I don't think that they can do anything about it. So Something you may notice right up front, I'm just going to talk about the differences because I'll take this motor apart, I'll show you the inside. It's not really any different than any other motor. If we can get it apart, it's not really any different than any other motor. It's got the magnet lip on the bottom. It doesn't have a rubber washer under the bell, so if you cinch the screw a little bit too tight, it's going to bind the bell. So you have to use Loctite on the screw, which it already comes with, and you can't cinch it down too tight. The laminations do look like at least 0.15, if not even thinner than 0.15. This is a quality motor, completely quality motor. The bearing underneath is inset, so it can be mount flush onto the surface of a frame. This motor can as well, just barely though. And the Avenger 2806.5 can also be mounted flush. The design, so everything about this motor is really great. I'm just going to point out the very interesting design choices that they make. And one very interesting one that they chose to make is that the bearing in there is a 9mm outer diameter bearing with a 4mm inner shaft hole, which is super interesting because even the Fywoo motor, which is an OEM motor of the same manufacturer as Xing or Xing or iFlight, has gone with a much larger bearing. Now the Avenger motor in the 2806.5 has a bigger bearing than the Fywoo, I believe. It's 1mm bigger. This is an 11mm. They're using a 12mm bearing in the 2806.5 from Brother Hobby. This one is using a 9mm bearing, and that's odd to me because it's not. You can definitely feel the difference with that large bearing. Absolutely, you can feel the difference. And also something else that's odd is that they're using the screw head of it is the smaller 2mm, I believe, or no, 1mm screw head socket, which is annoying because you have to use this tiny little screw, and it's possible to strip the screw or break your driver by putting that much force on that little screw. So aside from those two choices that they've made, which I think that they were really just limited because you can't really fit a larger bearing easily into a 25mm diameter stator without doing something to re-engineer the poles of the stator, and they're using these really nice windings which would be very difficult to re-engineer and still fit on the actual stator poles. I know that because I'm developing a bunch of motors right now which have a very similar issue that we're trying to work through. Anyways, aside from those really minor issues, I see nothing that is really alarming about this motor, other than also the weight. So the screw at the bottom, which you can really change the screw at the bottom yourself too, the small bearings, and the weight of this motor. Whereas the 2806.5 motor, even this one with the, oh no, never mind, this one is super heavy. Yeah, this one's 50 grams. I didn't realize how much it was. Anyways, this 2510 is 53 grams with the long wires, which I haven't even put on there. Here, I'll try to put all the wires on there. 55 grams with this motor with the long wires, whereas the 2806.5 Avenger is, I believe, 41 or 42 grams. So it's a much lighter motor, but I would argue that these weight differences are really not as significant in a 7-inch size because you are pushing so much power. But now let's talk about how it actually performs compared to other motors in the size that I've tried. Now, the motors that I would compare this against that I would say are all very suitable for 7-inch and I have tested are the Racer Star 2508, which I still think is a fantastic motor for 6-inch and 7-inch. I really do think that's just an amazing value motor for 20 bucks. You just can't beat it because it is a really quality made motor. Well, for the most part, it's using weaker metal and it doesn't have a titanium shaft that the higher end motors do. Other motors would be the Avenger 2806.5, also this Fywoo 2806.5, also the iFlight Xing 2806.5, and I think there's another motor as well. And there's a couple other motors that are coming out around that size also, which, you know, Brother Hobby kind of started that craze with the 2806.5, and people are kind of just jumping on board to make a Me Too product. But all these Me Too products are great, and these are all really high quality motors. So how does this thing perform? I was expecting this thing to feel very comparable to the 2508 from Racer Star, but it does not feel comparable at all. It doesn't feel anything like the 2806.5. What's really interesting here is that there is a very drastic difference between the 2806.5 Avenger and this 2510, which are the two motors I'm going to primarily focus on because they have the most similar construction. I'll talk about the others as well. What you can see in this first flight is that I was truly taken aback by the performance of the quad. Also, I stuck a brand new RunCam Eagle in my quad, which I asked RunCam for a half dozen cameras just for my own use because I ran out of them, and it was just easier to ask them because they're always sending me stuff anyways. They just said, can you send me a couple cameras? Like, I'm out of these cameras, and it's just easier for you to send it to me in the next shipment. They sent me a handful of returned cameras from users, so I have a whole bunch of half-busted, screwed-up cameras. And right now I'm flying with the camera in 16:9 mode instead of 4:3, which I didn't realize, and the sky is purple and it's messed up. That's why it's not flying very well. But besides the point, the power was something that I needed to adjust to because it is definitely very different than any other motor in 7-inch that I have flown. And I'll talk about DRL's decision a little bit later as well, but the flight performance of this motor is genuinely different, as I've said, than the other motors that I've tested. When I adjusted to the power and adjusted the camera and got it working appropriately, it flew pretty well. I would say that actually the 2210 Sing motor that they made me custom to test on 7-inch flew very similar to this motor because it is a very tall motor, and it's a 22 size, it's a 25 size. And what's really nice is that I can very easily tell that wobble problem between these motors that I was having, that I still have on all of my quads, that I'm trying to work around. Now, I keep talking about this wobble problem, people keep asking me what it is. If you punch the throttle and then drop the throttle really quick, you get this waver of the quad in the air where it kind of loses its attitude, and that comes from sort of the throttle dropping too fast and the quad not having the RPMs to properly maintain its attitude in the air, which I wish that I could just increase the effectiveness of air mode. But to resolve that issue, you just need to drop the throttle slower or increase your minimum RPM on the throttle, which is a negative thing that you don't want to do. Anyways, moving on, that wobble issue is much more drastic in this motor, and you can absolutely 100% feel it when you fly it. You can just very clearly tell the difference. The control of the prop, the control of the quad with the 2806.5 is just better at the lower half of the throttle for whatever reason. And I say for whatever reason, and I'm going to talk about that a little bit later in the little controversial section at the end where I just share my experiences. This motor kind of races through the lower half of the RPM very quickly, so it's very touchy to fly in the throttle range. You kind of have to be delicate on the throttle in the lower 50%. Once you get past 50%, in the top 50%, it's much more manageable. And the flight performance of this motor is actually very good. It may do an even better job than the 2806.5 at the random bobble management of 7-inch. I did fly it in higher wind situations, and it did fly hard to compare because I haven't flown the other ones for a minute, and it's just, I watched the video. They're very comparable. However, this one does seem to do just slightly better. What you do give up for maybe that tiny slightly better bobble performance is the control of the quad. It's not bad by any means at all, and as long as you're higher up on the throttle, it is very, very comparable. You'd be very hard pressed to tell a difference, but it is definitely slightly less control feel than the 2806.5. And I keep talking about control feel, and I know a lot of my viewers are relatively new to this sport, and they may not have tested as much things as I have. When you test a quad that has phenomenal control, you start feeling all the other quads that don't have as good of control. And things that, I won't even go over things that increase control. I'll leave that at the controversial section at the end. So, why do I think that DRL actually made a great decision going with this motor over the 2806.5? Well, first and foremost, they sent it out to a bunch of their pilots, and they all said they preferred this motor. But I think that they preferred this motor because it does better at higher RPM, and it races through the RPMs at lower RPM much more freely. And so I think it's a great decision for a racing quad. I don't think it's a great decision for a 7-inch kind of acro quad where you do want fantastic control at kind of slower speeds, not at super high race speeds, because you do get better control with the wider motor. However, with this motor, which I haven't mentioned yet, I think you can squeeze just a touch more flight time out of your battery because it feels like the motor does have more torque. Now, this is where it gets controversial. I'm going to share my experience only. You don't have to agree with me. You're more than welcome to ask questions in the comment section below, but please note that this is just my experience. I'm just sharing with you what I've learned after testing so much of this stuff over 5 years. So you can't really directly compare, which previously I was wrong about as well. You can't directly compare motor sizes and expect them to be predictable. So if you compare a 2306 to a 2207, they're not directly comparable because it's not just the motor size that matters. It's the whole construction of the motor that is what makes the motor what it is. You can't just say a 23 size stator will always have more torque, will always be better control, will always have better feel. If the two motors are made to the same exact spec, with the same materials, same construction quality, same everything, you can begin to compare them. However, also keep in mind that when you go from motor to motor, they all have to be re-engineered from the get-go. That means they have to change the windings, they have to change the magnet structure, they have to change the way the stator is put together, they have to change the bearings. Everything is different about the motor, even just changing it from a 2207 to a 2306. It is very different. But motors that are very similar can be compared. And just between 2306 and 2207, the 23 size stator, to me, across many motors that I've tested, feels like it does seem to have slightly better handle on a 5-inch prop compared to a 2207. Now, that does not mean that there are 2207 is bad. As you've seen with many other people that have tested these motors side by side, you can't really tell a difference if the motors are not the same. Some 2207s are built to a much higher spec than 2306 motors. Therefore, they will have better control, better torque, better performance across the board compared to a lower construction 2306. So it's more important to focus on the actual quality of the motor and how it's constructed rather than just looking at the size or the kV of the motor. Also, torque. Torque is commonly misused across all motors in this industry, and again, I'm focusing on multi-rotors, FPV multi-rotors only, in a very narrow subset of motor markets. I don't know about cars, I mean I do, but I'm not talking about cars, bikes, fixed wing planes, none of that stuff. I'm strictly talking about FPV quads and the control performance that we feel when we are flying these things. Torque has been misused entirely because it's still common today to think that lower kV means higher torque. That is the farthest thing from the truth. In fact, higher kV usually, not always, means slightly higher kV, not like drastically higher kV, usually means more torque in the motor. The reason for that is, just on a layman terms, it's because the motor has the potential to draw more power, and it's using that power to create more of everything. Therefore, across the board, it has more torque. It's less efficient because it is drawing more power, but that depends on your definition of efficiency. If you're looking for speed efficiency, well, then that's a totally different definition as well. So I've kind of just thrown out the word torque there, but it's a loaded term. What I mean by torque in this particular very narrow subset of applications is that if the motor has more torque, arbitrarily of size, kV, everything else, just a very high level, if the motor has more torque, it will tend to be more jumpy or more poppy at the lower end of the throttle range, which means that you can potentially run a larger prop on it. However, you throw a wrench in that when you start trying to manage that prop and the delicate RPM changes, which is how we actually control our quads, is these delicate and quick RPM changes. Now, I think I've probably already lost most of you guys, but I'm still going to keep going here, and I'm probably going to get a bunch of flame for this stuff, but whatever. I just like talking about it. So, torque is how these things live and breathe, and without torque, we don't have control. We don't have the ability to do what we want. But the torque curve in a motor is different depending on how it's constructed. Everything about the motor matters. People commonly think that electric motors have all their torque at 0 RPM, and that is mostly true, but as you go up in RPM range, torque the torque curve falls off and the power, which is just the ability to do work, pours on. And depending on where the motor is in the RPM range, it may have more or less different whatever, some weird kind of torque curve or power profile, which allows the prop to be managed differently depending on what prop you put on it, how much load the prop is, how big the prop is, how fast you're spinning the prop. Everything matters, and everything does impact the way the quad performs. Yes, you can throw any prop on any motor and it works, but if you're trying to fine-tune things and get to that next level of performance or next level of tuning, you kind of need to pay attention to all this stuff, and a lot of times you get it wrong. I get it wrong a lot of the time because it's really hard to predict how these things will perform. So it's really like the specific motor with a specific prop, with a specific frame and the specific setup that flies so fantastic, and that's where setups that are well known seem to fly very well. And also the code has a massive play in this performance as well. The code is designed for a very special level of performance, which has been increasing over the years, so the code has adjusted to work in the performance range. Now, I'm not talking about performance as in power to weight. I'm talking about performance as in the proportions of the quad and how much thrust it gets, or how it's the quad's ability to manage its weight and its inertia with respect to the code and the input and execution of it all. Again, I probably lost all you guys. I could talk about this stuff forever. But what I'm trying to get at is that this motor, the Avenger 2510, feels like it has more torque in the lower half of the range, since it just zips through the lower half of the RPM range, than the 2806.5. And that's very, very weird because it has much more of a wobble issue than the 2806.5. So maybe at the very bottom end of the torque, the 2806.5 is far better, as in the bottom end of the RPM range, the 2806.5 is definitely better at managing the blades. But as you start pouring on the RPMs, this motor's power range seems to take over sooner, and it races through the RPMs quicker than the 2806.5. What I'm trying to say is that the 2806.5 is a much more linear throttle performance than the 2510 motor. You're going to get a much more zip through the bottom half of the RPM range, and then you're going to have more squishy control at the top half of the RPM range, which is why I believe that DRL did a good job in testing these, and I'm pretty sure all the racers agreed when they tested them on a racetrack, not on like an acro cruising kind of setting, different applications totally, they chose this 2510 over the 2806.5. That's it. I hope this was I hope I didn't confuse too many people. I may have said things in a way that may be interpreted differently, but I think that more people will just have thoughts about everything that I talked about rather than decide to object to things. I'm really just trying to get people to think about things, because this stuff is a lot more complicated than meets the eye than right off the bat. And so just think about this stuff. I don't know everything. I definitely don't know everything. I am not an engineer. I've just tested a lot of this stuff and spoken to a lot of engineers about this stuff, and it's just based on my experience and testing all this stuff and designing a lot of things with these manufacturers. This motor is great. However, I would prefer the 2806.5, but it's up to you to make your own decision. Take care. Floss your teeth. See you later.